Good day, ladies and gents. All right, so we're going to be doing the distance formula part 2. Okay, so remember, your hot topic should be sitting next to you, helping you out. So distance formula right here, where you subtract the numbers and do Pythagorean theorem. And midpoint, you add them together, divide by 2. So the 2 ideas you want to sit next to you while you guys are working on this. That will help you out a lot. Okay, so on this first one, this is what's going to be on your test. Everything's going to build up to these ideas right here. So make sure you take the time and actually understand what's going on. And I get it, you guys hate word problems. You just break it down into little steps. Okay, so in the diagram, a bike ramp built on a hill has these vertices, A, B, C, and D. All right, so here are those vertices. Now, to make sure that the ramp is sturdy enough, Raphael is going to add a straight steel tubing that connects the midpoints. So we're going to be connecting the midpoints of AD. So we want the midpoint of A to D, so right about here, and the midpoint of C to B. So we want to connect those two midpoints. Now, do you know what those are? No, you don't. So that's the first thing we have to find. We have to find the midpoint of A to D. We also have to find the midpoint of C to B. That's the first thing we have to do. We have to find those two midpoints. And we're going to connect those. What would be the length between in radical form? So we want to find this orange distance. That's the whole point of this. So once you find those two coordinates, you're going to find the distance. So distance between those two midpoints, mid to mid. So we have, those are our steps. Find the midpoint of A to D, find the midpoint of C to B, and then go find the distance between the two. All right, so once you have that laid out, everything else falls into place. All right, so your A, and your A was at negative 5, 1, and your B, or we want D, right? So negative 2, 7. And we want to find the midpoint. And I got those coordinates up here. So what I'm going to do is I'm going to zoom in. All right, so we want the midpoint. So add them together, divide by 2. And we get negative 7 over 2, which is negative 3.5. And 8 over 2, which is 4. All right, so all we did was add them together, divide by 2. And does that look like it's in the right place? Does that look like negative 3.5, comma 4? And it's kind of hard to tell on this one, but you can definitely tell on a prettier graph that that's in the correct location. So if you don't like the graph that they gave to you, regraph it, and that will help you out a lot. Okay, on this next one, we have C to B, right? C, we were told was 3, 5, and B, so this was A and D, so this was, that was C, and B is at 6, negative 1. All right, so we want to add them together. 3 plus 6 divided by 2. That's 9 over 2, which is 4.5. And 5 plus negative 1 over 2, which is 4 over 2, which is 2. So those are the two coordinates. And you can't really tell on this one, but if you actually had a better graph like this, it would be in their correct location. And your final step is to find the distance between those two coordinates that you just found. So now that you have those two coordinates, so negative 3.5, comma 4, and 4.5, comma 2. Distance, we don't like distance. So we're going to subtract those. Negative 3.5 minus a 4.5, and 4 minus 2. We get negative 8 squared plus 2 squared. That's 64 plus 4. I ran out of room, so I'll put it up here. That is the square root of 68. And these tricky little buggers told us to simplify radicals. So what square can you take out of 68? Okay, well, square root of 68, right? So so 68, I want to see if I can take any radicals out. So can I take out the square root the square of 8, which is, can you divide by 64? Nope. How about 7 squared? Nope. How about 6 squared, which is 36? Nope. How about 5 squared? Nope. How about 4 squared? Yeah, nope. That's a decimal. 3 squared? Nope. 2 squared? Yeah. I could take out a 4, right? So that's a square root of 4 times the square root of 17. Because 2 squared was 4. All right, what's the square root of 4? 2. So 2 square root of 17 is my final answer. So 2 square root of 17. So 2 square root of 17. You write that into your final answer right there. So 2 square root of 17. That was your final answer. So 2 square root of 17. Okay. All right. And just in case you're curious, that was approximately equal to 8.246, in case you were curious. All right. Number 2. Once again, this is the whole point. This is the stuff that's going to be on your test, these kind of ideas. All right. The city of Jacksonville wishes to build a sidewalk diagonally across a rectangular shaped park. Okay, so there's a rectangular park. All right, so rectangular park that is 135 by 180 by 135 by 180. And we're going to have a sidewalk that goes diagonally, so like this. So this is a sidewalk right there. How much will the city spend if it costs $24 to have the sidewalk built? So I want to know, how much would this be built? And we know it's $24 per foot. $24 per foot. So before we know how much it costs, we need to know how long it is. Okay, so you guys see that triangle? We just want to do Pythagorean theorem. So 135 squared plus 180 squared. So 135 is 18225 plus 180 squared, which is 32, and I'll zoom in because I know you guys can't really see that. All right, so 32400. We get 50625 equals x squared. Square both sides. Ooh, cool. We get 225 is equal to x. Now, these tricky little buggers. That is an option right there, isn't it? But did you answer the question? They didn't ask you how long it was. They asked you what was the cost. How much will it cost? And these tricky little buggers put that as an option, but that's not what we wanted. We know that it's $24 per foot. We know it's 225 feet. So times that $24, and we would get 5400. So it costs $5,400. So 5,400. That, see these tricky little buggers right there. That's tricky. So that's so $5,400 was the answer. Those tricky little buggers. So be careful with that. Make sure you're answering the question that they asked. All right, number 3. Okay, so for this one, we want to graph it, right? So we are at J is -3, 1, 2, 3. And if you don't like this graph, if you don't like that particular graph, remember there are graphs on the very back of these pages, or you can use the back of the other packet. So you can put these on here if you prefer. There's always these extra graphs. Okay, so we have -3. So 1, 2, 3, +1. There's my J. Sorry, only helps if you can see it. We have 1, comma, -5. 1, 2, 3, 4, 5. That's my K. We're at 7. 1, 2, 3, 4, 5, 6, 7, comma, -2. 1, 2. There's my L. And 1, 2, 3, comma, 4. 1, 2, 3, 4. And that right there is my M. Okay, and had a straight edge. I love playing this game. There it is. Okay. Your ID works just as well. ID would probably be a lot simpler. Okay, so here is the thing, and they want to know what the perimeter of the fence is. They want to know what the perimeter is. So I want to find all those little distances. So J to M. So J to M. So you could either do this algebraically by using the coordinates, or you could just count your hops. So whichever one you prefer. So this right here, I want those right there. So I want that distance. Or we can just do J to M. So that is -3, 1 and 3, 4. Okay, when you subtract those, you get 1, 2, 3. And this is 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5. Yep, 6. All right, so we get 6 hops, and this right here is 3 hops, right? So, or you can do -3 minus 3, which is -6. 1 minus 4, which is a -3. So all this will still work. So it's a 6 by 3 at the very least, no matter how you look at it. So that would be, so you square those, you get 36 and a 9, and you add them together, you get the square root of 45. Because you square both sides. All right, that's J to M. Okay, so M to L. So M to L, you would count your hops. So I always go from the point to the corner. So 1, 2, 3, 4 hops. By 1, 2, 3, 4, 5, 6 hops. We get 16 plus 36, which is 52. So we got the square root of 52. All right, and then we have K to L. I'm making a right triangle right here. Okay, and we get 1, 2, 3 by 1, 2, 3, 4, 5, 6. So by 6, and you get 9 plus 36, which we actually did earlier, right? And we got the square root of 45. And finally, J to K. So I have a pretty good guess of what it's going to be. I think it's going to be square root of 52. So let's see. 1, 2, 3, 4. Yep, so it's a 4 by 1, 2, 3, 4, 5, 6. Yep, 4 by 6. We did that earlier. We got the square, so 16 plus 36, which is square root of 52. Okay. Okay, so we got those distances, right? And so what we're going to do is we're going to add them together. So square root of 45 plus square root of 52 plus square root of 45 plus square root of 52. And when you add those, you get 27.83861,297. So that would be our distance. However, they said every single hop was 10 feet. So we just have to multiply this by 10. So each one of those hops was really 10 hops. So 278.3861297. So I kind of moved the decimal over. And they said to round to nearest foot. So that's nearest whole number. So the question is, are we staying at 278, or are we rolling to the next number, 279? That decision's made by that 3. Did that make it over the hill? No, it did not. So because that did not make it over the hill, it rolled back, our answer is 278. All right, so that's our final answer. Sweet, we're getting closer to getting done. All right, we're going to flip the page, and we're going to go to page 20. Page 20. Here we go. All right, so this should actually look familiar because we already talked about this idea. We're going to find the length of the segment formed by the midpoints of A to B and C to D. And then they purposefully did not put this on a graph. So this is not drawn to scale. Now, there are a couple different ways how to look at this. One way is algebraically. So let's do that first. let's do that first. Okay, so if we do this algebraically, we need to find the two midpoints. So I need to find the midpoint of A to B, then I need to find the midpoint of C to D, and then we need to find the distance of mid to mid. All right, so midpoint of A to B, so -8, 3, and -6, -3. So we're going to subtract those. We're going to subtract them, and we're going to do Pythagorean theorems. So minus -6, and 3 minus -3. And we would get, so -8 minus -6, we get a -2. And 3 minus -3, we get 6. So that's 4 plus 36, which is the square root of 40. So if you had made a little mother of pearl, we're supposed to do midpoint. I'm a dork, but I'm 16 minutes in, so I'm not doing that again. So I actually was like, wait, I want the middle of this. I started a graph, and I'm like, wait a minute, what a dork. I'm supposed to add them together, divide by 2, because it said midpoint. So I'm not even following my own instructions. Okay, so we're supposed to do midpoint. So we're supposed to add those together, divide by 2. So let's try that again. So that would be -8 plus a -6 all over 2. That would be -8 plus a -6. We get -14 over 2, which is -7. Okay, and we have 3 plus a -3 over 2, which is 0 over 2, which is 0. Which is where we're supposed to be, -7, negative, so -7, 0. That does feel like the right spot. All right, let's try again for this other one, midpoint. So C was at 8, -2, and D was at 12, 8. Add them together, divide by 2. So 8 plus 12 over 2, 20 over 2, which is 10. -2 plus 8 over 2, that's 6 over 2, which is 3. All right, let's see. So about 10, 3. Yeah, that feels about right, roughly, right? And now we want to find the distance between these two, right? That's the whole point. Find the distance between those two. So to find the distance, we have -7, 0 and 10, 3. And we want to find the distance. So this one we subtract. So -7 minus 10 squared plus 0 minus 3 squared. We get -17 squared plus -3 squared. Okay, so -17 squared is a positive 289. -3 squared is a 9. Add those together, you get square root of 298, which is D. Okay, so that was one way how to do this. Now, let's talk about the other way. All right, so the other way to look at this was this. Use the multiple choice to your advantage. Distance cannot be a negative number. Distance. How far is it from here to the football field? You can't say, oh, it's -3 miles. Like, no. So it's definitely not B. It's definitely not C. It's between these two numbers. It's A or D. Now, if you put that into your calculator and give me the decimal, 3 square root of 2, you get 4.242 blah, 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 blah. Okay? And the square root of 298, you get 17 point blah, 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 blah. Right? So 17.262, whatever. Okay. Now just use your paper, right? So I'm just using scrap paper here. Just using scrap paper. I know the distance is from here to here, right? Roughly. From here to here. Now let's think about this for a second. Now if we use the graph, I know from here to here is 8, right? So I know that distance is 8. So if we actually put this on the grid, it would be a lot better. So I'm just making hops here. I know from here to here is 8, right? So from here to here is 8. From here to here is another 8. So that would be 16 now. And so I know I'm past that, right? So I know it's past 16. So it has to be D. There's no other answer. So we could have either done this algebraically, or we could have just measured the freaking sucker right there and on your graph and use the multiple choice to your advantage. So that does the job too. All right, next problem. So on this problem, we said Vanessa travels from her home in Jacksonville. She goes to Merritt Island. She goes from here to here. Then she drives to Orlando to go to Disney. Boop, right there. And then she traveled home along this dotted line. Now, to the nearest hundredth of a mile, what was her total distance? Okay, so let's see. We know that she went 148. She went 148 miles. Then she went 46 miles. Then she went from Orlando to Jacksonville. So the only thing we're missing is O to J. So let's go find that real quick. So O to J, we know for the Pythagorean theorem, right? Put your finger on the right angle. We know that that would be x squared plus 46 squared is equal to 148. All right, so 46 squared, so x squared plus 2116 is equal to 148 squared, which equals 21904. Subtract 2116 from both sides. You get x squared is equal to 19788. Square both sides. And you get x is equal to whatever the square root of that sucker is, right? So approximately 140.66988262. So OJ is that big long decimal, 140 point blah, 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 blah. Now remember, even though I didn't write it all, when I put it into my calculator, I'm going to use every single decimal. I'm just not going to write it every single time. I just know I'm going to go look for it right there and type all those numbers in. Okay, and so all we have to do now is add 148 and 46, and we pop out with 334.66988262. They said to round to nearest hundredth. So the question is, are we staying at 334.66, or are we doing 334.67? Okay, sorry, that's a little ugly, so I'm going to rewrite that. Because there was 334.66, or are we going to 334.67? That's the question. And that decision is made by the number after, which was a 9. 0, 1, 2, 3, 4 versus 5, 6, 7, 8, 9. 9 rolls to the next number, so that's our answer. So 334.67. And that's your final answer. Okay, last problem. Okay, number 6. Okay, triangle ABC represents the trail around Losco Park. If each unit represents 7 miles, okay, so at the end, I'm going to multiply by 7. Determine the perimeter. So we have to find the perimeter of this. So A to B, I'm just going to make little right triangles. This is a perfect example of starting at the point, then going to the edge. Because a lot of people, when they count this, that's 1, 2, 3, 4, 5, 6. They would have stopped too early. So make sure you start at the point, then go towards the corner. So that is 1, 2, 3, 4, 5, 6, 7 hops by 1 hop. Or 1 hop by 7 hops. So we get 49 plus 1, so square root of 50. All right, B to C. So B to C, so start at the point. Another example of ending too early. So start at the point, go towards the corner. 1, 2, 3, 4, 5, 6. That's 6 hops by 1, 2. We get 36 plus 4, which is square root of 40. And A to C. A to C, making a right triangle. Start at the point, go towards the corner. That is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. And we get 25 plus 25, which is square root of 50. Okay, we want the perimeter, so we're just going to add all those together. So that would be, sorry, that was supposed to be underlined. Perimeter is square root of 50 plus square root of 40 plus the square root of 50. When you put that in the calculator, you get 20.46669094. And they said to round to nearest 1,000, but we can't do that yet, right? We still need to multiply by 7. So multiply by 7. So no rounding until after you multiply by 7. So I'm just putting that back in my calculator. Square root of 50 plus the square root of 40 plus the square root of 50. And then I'm going to multiply by 7. And I get 143.2668366. Now we can round. So no rounding until then, right? So now we can round. We go to nearest thousands. So are we staying at 266? So 143.266, or we're going 143.267. That decision is made by that 8. 0, 1, 2, 3, 4 versus 5, 6, 7, 8, 9. That 8 rolls to the next number. So 143.267 is my final answer. And we're done, guys. That is phenomenal. Make sure you guys complete that packet. And the only thing left is to work on partitions later. Hopefully that helped you guys out. Have a great and wonderful day.